Connected.
Hello students, today we are going to study one of the very important topic attached to the Newton's laws of motion, that is friction. The frictional force, as the name indicates, as the people understand that it opposes the motion, but it is not so. Friction always do not opposes the motion, many a times it supports the motion also. Frictional force are of two types, static frictional force and dynamic frictional force. When two surfaces remains at rest, then frictional force acting on a body is called static frictional force. When there remains relative motion between two surfaces, then frictional force acting on a body is kinetic friction or dynamic friction. Let's understand the concept of friction, okay? The direction of friction opposite to direction of intended motion. Force of friction is partially independent of the microscopic area of the surface in contact and relative velocity between them. If it is not high, it depends on the nature of material of the surface in contact, that is force of adhesion and their roughness and smoothness. Now let's see an experiment. On the basis of that experiment, we are plotting a curve. Okay, let's see the experiment. Suppose this is a block of mass capital M. This is a pulley and a mass M is attached to the string. Okay. Now what happens when the mass is 0? When this M is 0, tension in the string is also 0. And here no opposing force is there, that frictional force will also be 0. So what happens when mass is increased? Dear student, when the mass is increased, tension in the string also increase. If the block of mass capital M do not move, means frictional force stopping the motion also increases. So what we are doing, we are continuously keep on increasing the value of M, small m, okay? We are continuously keep on increasing the value of small m. Then what is happening? Tension in the string continuously increasing, then is this small m frictional force is also increases, okay? A stage comes when tension in the string becomes so high that this frictional force reaches to the limiting value, which is called maximum static frictional force, maximum value of static frictional force, okay? That is called limiting frictional force. And even after that, if we increase the mass, then what happens? The block starts sliding. So what you understood, what you come to know? Static frictional force is a self-adjusting force. Static frictional force is a self-adjusting force, okay? Its value ranges from 0 to FL. What is FL? FL is limiting frictional force or maximum value of static frictional force, that you can see in the graph. This is frictional force and this is net applied force. When the net applied force is increased, static friction increases, okay, and reaches to the maximum value, which is equal to mu s into r or mu s into n. This r is the normal reaction exerted by the contact surface. And dear student, what is mu s? Mu s is coefficient of static friction. So what we have seen, if net applied force is 0, then static frictional force will also be 0. If net applied force is less than limiting frictional force, then body do not make relative motion with the contact surface. Body do not make relative motion with the contact surface. And frictional force is static in nature, okay? And what is value of static frictional force? Static frictional force will be equal to F net, okay, net applied force. Dear student, the direction of static frictional force remains opposite to direction of attempted motion, okay. The direction of static frictional force, because in case of static frictional force, body do not move, and the direction of static frictional force remains opposite to direction of attempted motion, okay. Now, if net applied force is equal to limiting frictional force, then frictional force in this situation is equal to net applied force, that is equal to FL. Till this situation, body do not move, do not have relative motion with the contact surface, okay. So general condition, till a body will not have relative motion with the contact surface is what? F net less than equal to FL. This is the general condition, okay. This is the general condition till a body do not have relative motion with the contact surface, okay. F net less than equal to FL, okay. But dear student, if applied force is again increased beyond the value of this FL, okay, then what happens? The body starts moving. The body starts moving on the contact surface, okay. In that situation, friction also acts, but that friction is called kinetic friction, relative, the dynamic friction, okay. And its value is constant. See here, this situation comes when net applied force becomes more than limiting frictional force. In this situation, frictional force is kinetic friction force whose value is mu k into n. Dear student, this Fk remains lesser than Fl. This n is the normal reaction, okay, or R is the normal reaction. And what is mu k? Mu k is coefficient of kinetic friction. And it is less than mu s. Therefore, Fk is less than Fl. So what you observed? It is more difficult to start the motion than to maintain it. It is more difficult to start the motion than to maintain it, okay. So you understood when the body will move, when the body will not move. And what is direction of kinetic friction? The direction of kinetic friction remains opposite to relative motion, opposite to relative motion. Let's see the direction of kinetic friction and static friction. And also we will see amount of static friction and kinetic friction. Dear student, if this is a mass 4 kg and coefficient of static friction is 0.1 and applied force is, if applied force equal to 0, if applied force equal to 1 Newton, if applied force equal to 2 Newton, if applied force equal to 4 Newton, then what is value of static friction? Let's see now. Dear student, in this situation, the limiting frictional force this is the normal reaction by the contact surface. This is the earth gravitational pull, that is weight of body 4g, this is 4 Newton. And this is limiting frictional force Fl equal to mu s into n. This is 40 Newton. This is 4 Newton. So dear student, when applied force is 0, in this situation frictional force is 0, that is static, and frictional force When applied force is 0, frictional force is 0. When applied force is 1 Newton, frictional force is also 1 Newton. When applied force is 2 Newton, frictional force is also 2 Newton. When applied force is 4 Newton, frictional force has reached to the limiting value, that is 4 Newton. And what is direction in this case? Direction of attempted motion. In all cases, direction of frictional force. Since direction of applied force is right side, so direction of frictional force will be left side. Okay, this is direction of frictional force in this case. Okay, left side. This is the answer. Okay, now let's see. Suppose these are two blocks. Mass here is 2 kg. Mass here is 4 kg. And let us assume coefficient of static friction is 0.2. So total limiting frictional force in case of first block is 0.2 into 2g, that is 4 Newton. And total limiting frictional force in case of second case, this is 0.2 into 4g, this is 8 Newton. So total limiting frictional force equal to 4 plus 8, this is equal to 12 Newton. Okay, now dear student, let's see the question. If we are applying here 10 Newton force, then we have to find what is value of frictional force between 2 kg and surface, what is tension in the string, and what is frictional force between 4 kg and the ground. Because total frictional force acting on the system is 12 Newton and net applied force on the system is 10 Newton. So in this situation, the block will not move. In this situation, block will not move. Okay. The maximum frictional force acting on the block on which net applied force or net attempted motion will have the direction. Okay. So here force is applied on the 2 kg 10 Newton. So on 2 kg block, maximum frictional force will be there and maximum frictional force will be limiting frictional force. Here limiting frictional force is 4 Newton. Okay. So between 2 kg and the ground, the frictional force between 2 kg and ground. And so the frictional force is FL1, this is equal to 4 Newton. Okay. Now for equilibrium of 2 kg, what is the relation? This is tension in the string and this is 10 Newton. So 10 plus this 10 equal to what? T plus 4. So T equal to what? This is 6 Newton. So tension in the string is 6 Newton. Now let's see the case of the 4 kg block. If we look at the case of 4 kg block, this is the tension in the string. And now limiting frictional force here, this is how much? This is 8 Newton. Since maximum value of static frictional force can be only up to limiting frictional force, but here in this situation net applied force is tension in the string, that is 6 Newton. So frictional force, static frictional force is a self-adjusting force. In this situation frictional force will be only 6 Newton. Okay, and this will be the direction. So what are the answers? Frictional force between 2 kg and the ground is 4 Newton. Frictional force between 4 kg and ground is 6 Newton. And tension in the string is how much? This is 6 Newton. Okay. So these are the answer to our question. Okay. Let's see another question. Suppose this is a block of mass 8 kg. Here is a force 20 Newton. Here is a force 36 Newton. And mu s equal to 0.2. Then what is the direction of the static frictional force? Now see here. Dear student, if we analyze the case, the limiting frictional force will be the normal reaction equal to 8g in this case. This is equal to 80 Newton. So limiting frictional force will be 0.2 into 80. This is equal to 16 Newton. Okay. And the net applied force on the system. See here in this case, the net applied force is 36 minus 20. This is 6 Newton. This is the direction of net applied force. Since net opposing force is also 16 Newton, so block will not move and the frictional force will act in this direction, which is equal to limiting frictional force. So answer is 16 Newton in acting in right direction. Acting in right direction. Okay, this is the answer. Okay. Dear student, now see some more definitions. Okay. Now let's see angle of friction. What is angle of friction? If this is the direction of applied force, this is the frictional force, and this is the normal reaction, then and this is the resultant of frictional force and normal reaction. Okay, the angle made by the resultant of frictional force and normal reaction. Okay, is angle of friction, which we write as tan phi equal to f upon n and f equal to mu into n. So tan phi equal to mu. Okay, this is angle of friction. Now, dear student, let's see angle of repose. One more very important definition. It is defined as the maximum angle of inclination with the horizontal at which a body placed on it just begins to sliding down. Suppose the mass of the block is m, mg is vertically downward. Weight of the block, if this angle is theta, then this is also theta. This component is mg cos theta, this component is mg sin theta, this is normal reaction. Okay, so what is mu s? Mu s equal to f upon r. What is frictional force? Mu into n. Okay, that is, and tan theta equal to f upon r. What is f? Frictional force, that is mg sin theta. What is r? Mg cos theta. So here theta equal to what? Tan inverse mu s. Okay, this fact is used for finding the coefficient of static friction in the laboratory. Okay, so dear student, what is angle of repose? It is the maximum angle of inclination. It is the maximum angle of inclination of a block kept on inclined surface till a body do not move on the inclined surface. It's called angle of repose. Okay. And what is rolling friction? The friction experienced by the body during rolling situation is called rolling friction. Okay. Now let's see a simple question. In the figure, two masses A and B. The mass of A is 10 kg and mass of B is 5 kg. Are connected with a string passing over a frictionless pulley at a corner of a table as shown in the adjoint. The coefficient of friction of A with the table. Here, friction coefficient is 0.2. Minimum mass of C, so that it is placed on A to prevent it from moving. Dear student, what we have learned? When net applied force remains equal to limiting frictional force or less than limiting frictional force, body do not move. Here friction is present only between A and the ground. Okay. So dear student, what is mass of B? Mass of B is 5 kg. So what is weight of B? This is 5 kg, 5g. If the block do not move, then tension in this string will be equal to how much? 5g. Tension in the string will be equal to how much? 5g. This is equal to 50 Newton. Okay. So to keep the blocks, if we want to prevent the block sliding, then here frictional force, this is MA and this is MC, and this is the normal reaction. This is frictional force mu n here, and n is what? MA plus MC into G. This should be equal to 50. Now we can see what is mu. In the question, mu equal to 0.2. What is ma? Ma is 10 kg. What is mb? What is mc? This is mc into g. This is equal to 50. So dear student, after solving this, we get 10 plus mc. This is equal to 25. So mc is how much? 15 kg. So mass of block C should be 15 kg. Okay. So out of 4 options, the correct answer is option 4. So option 4 is the correct answer to the given question. Okay. Now let's see a question. In the arrangement shown, mass of A equal to 1 kg, mass of B equal to 2 kg, coefficient of friction between A and B is 0.2. Here, dear student, coefficient of friction is 0.2. Mass of A is 1 kg. Mass of B is 2 kg. There is no friction between B and ground. Okay. The frictional force between A and B will be. Dear students, if A and B are moving together, frictional force between A and B will be equal to applied force transferred to block A. Now let's see. This is 3 Newton force. Keep taking friction to be internal force. MB equal to 2, MA equal to 1. This is so acceleration equal to 1 meter per second square. So force transferred on block A of mass 1 kg, this is equal to how much? 1 into 1, this is equal to 1 Newton. So frictional force on block A will also be 1 Newton. Okay. So answer to the given question is option 4. Option 4 is the correct answer for the given question. Okay. Now dear student, let's see a question. A body of mass 400 gram. 400 gram means 0.4 kilogram. Slides on a rough horizontal surface if the frictional force is 3 Newton. Find the angle made by the contact force on the body with the vertical and the magnitude of the contact force. Okay, contact force, frictional force is also contact force, N is also contact force, resultant of N and F will be resultant contact force. Okay, so dear student, what is the normal reaction? Normal reaction is the 0.4 into 10, this is 4 Newton. Okay, and the frictional force is how much? This is 3 Newton. So tan theta is how much? F upon N, this is 3 upon 4, this is 37 degree. And the magnitude of contact force is what? N square plus F square under root. This is equal to 16 plus 9 under root. Okay, that is equal to 5 Newton. Okay, so answer to the question is 5 Newton. The coefficient of static friction between the two blocks shown in figure is mu. And the table is smooth. What maximum horizontal force F can be applied to the blocks of mass M so that the blocks move together? Blocks move together. Together means what? Frictional force between small m and capital M should be static in nature. Frictional force between small m and capital M should be static in nature. And maximum value of static frictional force is what? That is limiting frictional force. So dear student, if the blocks are moving together and table is smooth, so force equal, if both the blocks are moving together, F equal to what? M plus M into A. So what is acceleration? Acceleration equal to F upon M plus M. Now, force transferred on block of mass M is Ma. This is equal to what? M F upon M plus M. If this is the force transferred, Mf upon M plus M, and this should be equal to limiting frictional force. Okay. Here, this is mu s mg. So what is being asked? The value of F. Okay. So F can easily be determined. What maximum horizontal force? Okay. This mf upon m plus m should be equal to msmg. Okay, now let's see the solution. mf upon m plus m, this is equal to mu s mg. Let's cancel. Let's cancel small m, small m. What is f? Mu s m plus m into g. This is the answer to the given question. Okay, this is the maximum force till the two blocks will move together. Till the two blocks will move together. Okay. Now let's see another question. Assuming the length of a chain to be L and the coefficient of static friction is mu, compute the maximum length of the chain which can be held outside a table without sliding. Let us assume this y length is enough to maintain that the chain will not move. Okay, so total mass, let us assume total mass of the chain is m of length L. So mass per unit length is how much? M upon L. This is mass per unit length. Mass per unit length of chain. So dear student, mass of the hanging portion. Mass of hanging portion. This is equal to how much? M by L into Y. And mass of the chain at the surface. Mass of chain at surface. This is how much? How much is the chain? L minus Y. Mass per unit length is how much? M by L. This is the, so to prevent sliding, what is the condition? Weight M by L, L minus Y into G. This is the weight. Mg, this is equal to normal reaction, and this is frictional force mu into N, and this should be equal to how much? Weight of the hanging portion M upon L, Y into G. Now what we need to find? We need to find the maximum length. Okay, Y. Okay, so M by L got cancelled, G got cancelled, so L minus Y into mu equal to Y. So dear student, in this question, see, L minus Y should be equal to Y upon mu. So L equal to what? Y 1 plus mu. So dear student, what is Y? Y equal to L upon 1 plus 1 upon mu. That is equal to L mu upon mu plus 1. This is the answer to the question. This is the answer to the question. Y equal to what? L mu upon mu plus 1. Okay. If we keep this much suspended portion, then what will happen? The chain will not slide. Okay, chain will not slide. So dear student, this was lecture 1. In the next lecture, we will be looking for some more problems to clear friction. Okay, thank you very much.